Somewhere in the vast silence of space, a star is being born. From clouds of cosmic dust to the heart of a blazing supernova, this is the untold story of a star's life. And today you're about to witness it all like never before. From our pale blue dot, we embark on a voyage through time and space to witness the birth, life, and death of stars. Our first destination, a stellar nursery glowing in the sword of Orion. Behold the Orion Nebula, a cosmic cradle of newborn stars located 1,344 light-years from Earth. If you've ever gazed at the constellation Orion, you've seen this nebula with the naked eye as a faint smudge in its sword. But through the eyes of a telescope, it transforms into a swirling masterpiece of gas and dust. Here, gravity sculpts collapsing clouds into protostars, some destined to ignite like our sun, others to blaze as colossal giants. Within these radiant folds, planets may already be forming, worlds unborn, waiting in the dark. This is where stars begin their lives. But not all stellar nurseries are so close or so bright. Let's venture farther to a hidden gem of the cosmos. This is Orion 85136444. A lesser-known nebula over 15,000 light-years away. Unlike Orion's grand spectacle, this nebula whispers secrets of stellar evolution in the southern sky. Here, massive stars flood the nebula with radiation, painting it in hues unseen by human eyes. Some of these stars will live fast, die young, and explode as supernova, scattering the elements of life across the galaxy. The iron in your blood, the calcium in your bones, all forged in such stellar explosions. We are quite literally made of stardust. Within these swirling cosmic nurseries, gravity works its magic. Gas and dust collapse under their own weight, forming dense cores, each one a potential star in the making. This is a protostar, a baby star still feeding on its surrounding disk. Temperatures soar, and magnetic fields funnel excess material into twin jets, shooting outward at 500,000 kilometers per hour. For 100,000 years, this protostar devours gas, growing hotter and denser until the moment of ignition. At 15 million degrees Celsius, hydrogen atoms fuse into helium. Nuclear fusion begins. The protostar is now a true star, but a tempestuous one. This T-Towery star is unstable, unleashing flares 1,000x stronger than our sun's. Over millions of years, it will settle into stability, but for now, it's a cosmic wildfire. Stars are rarely born alone. Here, in clusters like the Pleiades, hundreds of siblings shine together. Some will outlive the galaxies they're born in, others will perish in fiery explosions. But what happens when a star reaches adulthood? Next, the main sequence, the longest, steadiest chapter in a star's life. After the fiery tantrums of youth, a star settles into its longest and most stable phase, the main sequence. Here, it will spend 90% of its life burning hydrogen into helium in a delicate cosmic balance. Deep in the core, 15 million degree heat forces hydrogen atoms to fuse, releasing energy. This radiation pushes outward while gravity pulls inward, a perfect equilibrium that can last billions of years. The surface churns like a boiling ocean, with plasma cells larger than continents rising and falling. Even in stability, a star is never truly still. Not all main sequence stars are alike. Their mass dictates their fate. Red dwarfs, tiny and cool, they'll burn for trillions of years, outliving the universe itself. Sun-like stars, steady for around 10 billion years before their inevitable decline. Blue giants, massive and hot, they blaze brightly but die young, in just millions of years. But nothing lasts forever. When hydrogen runs low, stars like ours rebel, swelling into red giants, consuming worlds they once warmed. The next chapter is destruction. After billions of years of stable fusion, the star faces a crisis. Its hydrogen fuel dwindles, and without the outward push of energy, gravity begins to win. The core contracts, heats up, and the star prepares for its most violent transformation yet. At 100 million degrees, the helium core, once just ash, now ignites in a violent flash. Hydrogen still burns in a shell around it, but the star's balance is broken. Radiation overwhelms gravity, and the star swells into a red giant. In just a few million years, it grows 100x larger, swallowing planets that once orbited safely. Mercury, Venus, even Earth will vanish into its crimson glow. The surface cools to a deep red, but the star's heart rages. Convection cells the size of solar systems churn, hurling material into space. This is stellar recycling. The star seeds the galaxy with carbon, oxygen, and the building blocks of new worlds. Some giants, like our Sculptoris, spin out intricate dust patterns, a preview of the beautiful death to come. Our Sun, too, will become a red giant. Its surface will reach beyond Earth's orbit, melting ice moons and boiling oceans across the solar system. For a brief, eerie era, it will dominate the sky, a monstrous crimson orb. But this is not the end. It's a metamorphosis, one that leads to cosmic rebirth. What happens next depends on size. Small stars, like our Sun, will gently shed their skins into planetary nebula. But massive stars? They won't go quietly. After its expansion into a red giant, the star stands at a crossroads. For smaller stars, death comes gently, but for the massive ones, it arrives in the most spectacular explosion in the universe, a supernova. Deep inside, the star has been fusing elements into heavier and heavier ash until now. Iron fills the core, a cosmic dead end. It cannot release energy through fusion, and in less than a second, the star's heart implodes. At light speed, the core crushes into a neutron star or even a black hole. The outer layers, suddenly without support, rebound in a shockwave of doom. For weeks, the supernova outshines entire galaxies, blasting elements forged in its core across space. Gold, platinum, uranium, the very atoms in your jewelry were born in such explosions. The shockwave triggers new star birth, while the remnant, a magnetar or pulsar, spins wildly, beaming radiation like a cosmic lighthouse. What remains is a supernova remnant, a glowing nebula laced with heavy elements, and at its center, a neutron star so dense, a teaspoon weighs 1 billion tons. Some, like the Vela pulsar, spin 11 times per second, their radiation carving paths through the nebula's wreckage. But not all stars die in supernova. Smaller stars fade as white dwarfs, and the most massive leave behind black holes. Their stories and the echoes of their deaths shape the galaxy forever. A supernova marks the end of a star's life, but its corpse remains a dense, exotic relic. The most massive stars leave behind black holes, gravity so strong, not even light escapes. This one, Cygnus X1, is 21 times the Sun's mass, trapped in a deadly dance with a blue supergiant. As gas spirals into the black hole, it heats to millions of degrees, glowing brighter than galaxies. Yet beyond the event horizon, physics as we know it ends. These remnants are not just graves, they're seeds. The iron in your blood, the gold in your jewelry, all forged in stellar deaths. And from the ashes of old stars, new ones rise, beginning the cycle anew.